In a circle, if we have a straight line passing through the center of the circle, in a circle, if there is a straight line passing through the center of the circle and bisects any chord, So this is the chord here. The straight line passing through the center of the circle. This straight line is passing through the center of the circle and bisects this chord So once again, the straight line is passing through the center of the circle, and bisects any chord in the circle. So I proved before that the straight line passing through the center and bisects any chord is perpendicular to this chord, is going to be perpendicular to this chord, okay? So here in this example, we have a straight line, which is MC. MC, this small line segment. So this line segment is passing through the center of the circle, M here, and bisects this chord. AB is a chord. AB is a chord here. AB is a chord. So this line is going to be perpendicular to this chord. So this angle is 90. What is the size of angle A? We have here 50. This angle is 50, and this angle is 90. So the size of angle A is going to be 40 degrees. That's it. What is the size of angle A here, this example? We have angle of size 220. This angle is reflex angle. So the measure of this angle here is going to be 360 minus 220. 360 minus 220 equals 140. So the size of this angle is 140 in this triangle. And this triangle is an isosceles triangle because MA is radius and MB is radius. This triangle is an isosceles triangle. So the size of angle A is the same as the size of angle B because the triangle is an isosceles triangle. So the measure of angle A equals 180 minus 140 divided by 2 equals 20 degrees. If there is a straight line passing through the center of the circle and perpendicular to any chord, this straight line is passing through the center of the circle, and perpendicular to this chord. So this straight line bisects this chord. So remember 3 words: pass, perpendicular, bisects. If there is a straight line passed through the center of the circle and perpendicular to any chord, so we deduce that this straight line bisects this chord here. Here in this example, we have a straight line passing through the center of the circle, as you see here. This straight line passing through the center of the circle and perpendicular to this chord. AB is a chord. AB is a chord here. Once again, the straight line passes through the center of the straight line, passes through the center of the circle and perpendicular to any chord. So this straight line is going to bisect this chord. Okay. So here I want to get AB. If you managed to find AX here, So we can find BX, and from that we can find the length of AB. How can we find the length of AX? This triangle is a right-angled triangle, and the length of the hypotenuse is 10 centimeters, and the length of this side is 6 centimeters. So we can find AX to the power of 2 from this triangle colored in red. It's 10 to the power of 2 minus 6 to the power of 2. 100 minus 36 equals 64. So the length of AX, the square root of 64 equals 8 centimeters. Okay, AX equals 8. So BX equals 8. Why is that again? Because this line passes through the center of the circle and perpendicular to this chord. So this straight line bisects this chord. The length of AB in this case is going to be 16 centimeters. Here in the circle M, the angle AMD equals 30 degrees. Okay. And the length of AB is 10 centimeters. The length of AB is 10 centimeters. And AB is a chord in the circle. AB is a chord in the circle. And the straight line here passes through the center of the circle and perpendicular to it, to this chord. This angle is 90. So if the straight line, if you remember the three words I told you, passes through the center of the circle and perpendicular to any chord. If the straight line passes through the center of the circle and perpendicular to any chord, so this straight line bisects this chord. This straight line bisected this chord in this case. So the three words I told you, pass, perpendicular, and bisect. So here the length of AE is the same as the length of BE, and the length of AB is 10 centimeters. AB is 10 centimeters. So in this case, the length of AD equals 5 centimeters. Okay. I want to get the length of CD. So we can find the length of ME because if we looked at this triangle here, this triangle colored in green, this triangle which colored in green, we have an angle of size 30, and this triangle is right. And you know that the length of the side opposite to an angle of size 30 equals the half length of the hypotenuse. So what is the length of the hypotenuse here? The hypotenuse is going to be 10 centimeters. The hypotenuse is 10 centimeters. Okay. And MA is a radius in the circle. MA is a radius in the circle. So the length of MA is the same as the length of MC. Okay. Is the same as the length of CD. All of them are equal. So the length of CD is going to be 20 centimeters. Okay. Here in this example, we have this angle. MDA is right angle. Okay. And I want to get the size of X, and this angle is 2X. We studied in this lesson that the straight line passing through the center of the circle and perpendicular to any chord. This is the chord here. The chord is AB. So this straight line bisected this chord. So here AD equals DB. They are the same. And here we have a diameter. AB is a diameter. AC, sorry, is a diameter. And AM is radius. And MC is radius. So here we have a triangle. ABC is a triangle. And in this triangle, if you remember this information, we have studied it before. In this triangle, focus on this triangle. If there is a line segment, drawn from the two midpoints, of two sides of a triangle. Okay, so this line segment is parallel to the third side. The line segment joining between two midpoints of two sides of a triangle is parallel to the third side, and equals half of the length of this side, And because they are parallel, so this angle is 90, and this angle is going to be 90. Why is that? Because they are two corresponding angles. Okay? Like this, or F in English. So this angle is going to be 90. 2x equals 90. So divided by 2, x equals 45. Here in this triangle, this triangle is right. So we can find the length of AC. We can find the length of AC by using Pythagoras. So AC, because this triangle is right, AC to the power of 2 equal 13 to the power of 2 minus 5 to the power of 2 equals 169 minus 25 equals 144. So AC equals the square root of 144 equals 12 centimeters. So AC is 12 centimeters. Okay. And you know that the straight line passes through the center of the circle. And perpendicular to any chord. This straight line passes through the center of the circle and perpendicular to this chord. And if you remember the three words I told you, pass, perpendicular, and bisect. Once again, pass through the center of the circle, perpendicular to any chord. So this line is going to be bisect the chord. So here, the length of BC here equals 12. So what is the length of AB? AB equals 24 centimeters. Now I want to get the length of CD here. You know that MA is radius here. MA is radius in the circle, and MD is radius in the circle. MD is radius in the circle. So they are equal. The length of MA is the same as the length of MD because they are two radii in the circle, both of them. So MD in this case equals 13 centimeters. And we have MC, it's a small part from it. MC is 5. So subtract 13 minus 5 equals 8. So the length of CD in this case is going to be 8 centimeters. What is the measure of angle A? MA is radius in the circle and MB is radius in the circle. So this triangle is an isosceles triangle. So to get the size of angle A, just subtract 180 minus 90, then divide by 2. It's going to be 45. And this angle equals 45. How can we get the length of this radius? The length of the radius here, because this triangle is an isosceles triangle, so we can use 10, if you remember. We can use 10 here and here. This angle is right. Here is MA, and here's B. And this side is 10 centimeters. And this angle is 45. We can use sine or cosine. If you want to find sine 45, sine 45 equals opposite over adjacent. The opposite is MA. Sorry, the opposite over the hypotenuse. The hypotenuse here is 10. Sine 45 equals opposite sine in general. Sine is a ratio between what? Between the opposite and the hypotenuse. And the hypotenuse here is 10. So how can we get MA? MA equals 10 sine 45. And sine 45 equals 1 over root 2. So MA equals 10 multiplied by sine 45. If you remember, it's 1 over square root of 2. Equals, we can multiply by square root of 2, or we can write it as 10 over root 2. Just to simplify it, multiply by root 2 at the top and at the bottom. So that is going to be 10 root 2 divided by 2, which is 5 root 2. That's it. Or we can use Pythagoras. How can we use Pythagoras? We can write here x and x because they are the same. They are 2 radii in the second. And x to the power of 2 plus x to the power of 2 equals 10 to the power of 2. X to the power of 2 plus x to the power of 2 equals 2x to the power of 2 equals 100. Then divide by 2 both sides, so x to the power of 2 equals 50. By taking the square root of both sides, square root of 50. And the square root of 50 can be written as 25 times 2. So what is the x here in this case? It's 5, the square root of 2. So we can use the trigonometric functions, sine, cosine, or tan, or we can use Pythagoras. And you should be familiar with both of them. I want to get the length of AC here. So how can we get the length of AC? We are going to construct a construction. We're going to draw MD. Okay. And this triangle is right triangle. This triangle is right triangle. So we can use Pythagoras to find the length of MD. So MD to the power of 2 equals 9 to the power of 2 plus 12 to the power of 2. And 9 to the power of 2 is 81 plus 12 to the power of 2 is 144. Is going to be 225. So the length of MD is the square root of 225 equals 15. And MD is the radius in the circle. MD is the radius in the circle. Okay. And MC is the radius in the circle. As you see here, they are 2 radii in the circle. So they are the same. They are having the same length. So MD is 15 and MC equals 15 here. They are equal. So what is the length of EC here? Subtract 15 minus 9. Okay, so EC is going to be 6 centimeters. That's it. What is the area of this rectangle here? The length of AC equals 5 centimeters. Okay. And the length of AD is 8 centimeters. You know, each two opposite sides in the triangle are equal in length. So the length of AC equals the length of MD. They are equal in length. So what is the length of MD? MD equals 5 centimeters. Okay. MD equals 5 centimeters and AM equals 5 plus 8 equals 13 centimeters. AM equals 13 centimeters. How can we get the length of MC if you focus on it? MC equals the same length of AM. Why is that? I constructed a construction. Pay attention. What is the construction I have constructed? I have drawn MC. And because MC is the same length of MA, because they are two radii in the circle, radius here, they are equal. They are two radii in the circle. So the length of MC equals 13 centimeters. If you looked at this triangle here, we can find the length of CD. The length of CD by using Pythagoras. CD to the power of 2 equals 13 to the power of 2 minus 5 to the power of 2. 169 minus 25 equals 144. So CD equals 12 centimeters. Now we have the two dimensions of the rectangle, the length and the width, 12 and 5. So what is the area of the rectangle? The area equals length times width, 12 multiplied by 5 equals 60 centimeters squared. Here in this example, AB and BC are two chords in the circle. M, which had radius length of 5 centimeters. The radius length is 5 centimeters. And MD is perpendicular to AB. MD is perpendicular to AB. Perpendicular to AB. And intersects AB at D. If you remember, the three words I told you, pass through the center of the circle, perpendicular, and bisect. Remember them well. Pass through the center of the circle and perpendicular to any chord. So this line will bisect this chord here. So let's complete reading the question. X is the midpoint of BC. X is the midpoint of BC. And AB equals 8 centimeters. AB equals 8 centimeters. And the measure of angle ABC is 56. This angle is 56. This line passed through the center of the circle and bisected this chord. And bisected this chord. So, because this line segment passed through the center of the circle and bisected this chord, so this line segment will be perpendicular to this chord. So this angle is going to be 90. Okay. So we write since X is the midpoint of BC, then MX perpendicular to BC. And this angle equals 90. It's a given. And this figure is a quadrilateral. This figure here is a quadrilateral, as you see. The four sides here. This is a side. 1, 2, 3, 4 sides. And we have two angles of size 90, and we have an angle of size 156. So we can find the measure of angle DMX. Okay. So in the quadrilateral, or we can write since MDBX is a quadrilateral. Then measure of angle XMD equals 360 minus 90 plus 90 plus 56 equals 360. Okay. Minus 90 plus 90 plus 56 equals 34. 134. Sorry, 124. So this angle is going to be 124. This is the first required. And I want to get the length of DE. Focus on DE here. DE is a small part from the radius. We can construct a construction. We can draw AM. And the radius of the circle is 5 centimeters. The radius is 5 centimeters. So AM is 5 centimeters. And AB equals 8. AB equals 8. And here, MD is perpendicular. MD is perpendicular to AB. If you remember the three words I told you, pass through the center of the circle and perpendicular to any chord. So bisected this chord. The line segment here bisected this chord. So D is the midpoint. So AD equals DB equals 8 divided by 2 equals 4 centimeters. So here AD is 4 centimeters. How can we get the length of MD? By using Pythagoras. So MD to the power of 2 equals 5 to the power of 2 minus 4 to the power of 2. In this triangle, I'm talking about this triangle. Is 25 minus 16 equals 9. So MD equals 3 centimeters. MD equals 3 centimeters. Okay. And MD equals 3. You know that ME equals 5. Why is that? Because the radius of the circle is given as 5 centimeters. The radius here is 5. MA 5. And ME equals 5. They are the same. They are two radii in the circle. And MD equals 3 centimeters. So we can find DE. DE in this case is going to be 5 because the radius is 5 minus the length of this part here, which is 3. So 5 minus 3 equals 2 centimeters. That's it. Two concentric circle with the center M. AB is the chord of the greater circle and intersect the smaller circle at the point C and D. Okay. Prove that AC equals BD. Prove that AC equals BD. This is the greater circle, and this is the smaller circle. And they are concentric. The meaning of concentric, they have the same center. Let's focus on the small circle. Here in the small circle, we have a line passing through the center of the circle and perpendicular to this chord. And perpendicular to this chord. So from the smaller circle, EC equals DE. EC equals DE. So in the smaller circle, we have ME. We are talking about in the smaller circle. ME is perpendicular to DC, the chord DC here. So E is the midpoint. If you remember the three words I told you, pass through the center and perpendicular to any chord, so bisected this chord. So E is the midpoint of DC. E is the midpoint of DC. So the length of DE, the length of DE equals the length of EC. Okay, the length of DE equals the length of EC. They are equal in length. And from the larger circle, if you looked at the larger circle, let's focus on the larger circle. Okay. If you looked at the larger circle, you will find here, focus on the larger circle only. You will find a straight line. This is straight line here. It's passing through the center of the circle. Let's draw it here in this place. Here is the larger circle. And we have a chord here, which is AB, the chord AB. And ME is perpendicular to this chord. ME is perpendicular to this chord. So AE equals AB. So in the smaller circle, again, we have DC. DC is the chord in the smaller circle. And ME is perpendicular. ME is perpendicular to this chord. So we reach to a conclusion. I'm not caring about writing the proof. I focus on understanding, and you are able to write. Since in the smaller circle, ME is perpendicular to DC, so E is the midpoint of DC. So EC equals DE. This is the most important point you should know. They are equal. This is number one. And in the larger circle, you write the same. ME is perpendicular to AB. Okay. Because ME is perpendicular to AB, so E is the midpoint of AB, so AE equals BE. They are the same. Number two. So here in this circle, we have, look at the way I am coloring them. AE colored in red equals DE, which is colored in red. And I proved that EC, which is colored in black, equals DE, which is colored in black. If you subtracted 2 from 1, so AE minus EC is the same as BE minus DE. And when subtracting them, you will find AC equals BD. That's it. Here in this example, AB is a chord in the circle M, and AC bisects angle BAM. You can pause the video and try it, and when ready, come back and check your answer against me. AC bisects angle BAM. So this angle is the same as this angle. We can write here angle 1, just to put it at ease, make it easy. Angle 1 equals angle 2. They are the same. It's a given. By the way, it's a given. And D is the midpoint. D is the midpoint of AB. So because D is the midpoint of AB, so this angle is right. This angle is right. And I want to prove that DM equals CM. I want to prove that DM here equals CM. So pay attention. We have a chord. AB is a chord, and AC bisects. AC bisects the angle BAM. So angle 1 is the same as angle 2. They are the same. And intersect the circle M at C. If D is the midpoint, so this angle is right. Why is that? MD or D is the midpoint. D is the midpoint of AB. So MD is perpendicular to AB. What is the next? What is the next? This is the radius in the circle here. MA is the radius, and MC is the radius. So this triangle is an isosceles triangle. This triangle here is an isosceles triangle. So we can write simply angle 3 here. So angle 2 is the same as angle 3. So because MA equals MC equals R, so this triangle is an isosceles triangle. So the size of angle 2, the measure of angle 2 equals the measure of angle 3. And we have a given. The given is measure of angle 1, since measure of angle 1 equals measure of angle 2. This is a given. So the size of angle 1 is the same as the size of angle 2, and the size of angle 2 is the same as the size of angle 3. So angle 1, 2, and 3 are equal. Angle 1, 2, and 3 are equal. So from this and from this, we deduce that measure of angle 1 equals measure of angle 3. And they are two alternate angles. Focus on angle 1 and 3 only. This is angle 1 here, and this is angle 3. They take the shape of letter Z in English, if you remember. So here, angle 1 is the same as angle 3. So they are two alternate angles. They are two alternate angles. Then we can deduce that AB is parallel to MC. They are parallel. Why is that? Because we have two alternate equal angles. And because they are parallel and we have angle here of size 90, so this angle is going to be 90 because they are parallel. As you see here, this angle is 90, so this angle is going to be 90. Why is that again? Because they are two parallel lines. So you're right, since AB is parallel to MC, and the measure of angle ADM, the measure of angle ADM is 90, so the measure of angle M is DMC equals 92 alternate angles. Or we can use the information we know from our prior knowledge. If we have two parallel lines, this is L1 and this is L2, two parallel lines, and we have a line perpendicular to one of them, so this line L3 is going to be perpendicular to the other. So you're right, since AB is parallel to MC and MD is perpendicular to AB, so that leads to being MD is perpendicular to MC. That's it. I hope you enjoyed this session. See you in the coming episodes. Goodbye.